Hello, this is the second part of the a series of videos where we are going to take a bit kind of interesting algorithm problems and then try different AI coding tools and then see how much useful these tools are, or how can we use these tools for different kind of use cases. And in the first part of this video, we went through speculative decoding. We describe how speculative decoding algorithm works. We went through a paper where this algorithm was proposed for the first time 2 years ago for fast inference leveraging LLMs. We went through the algorithm, we described the algorithm. We also went to the repository where we had the implementation, this repository where we had a notebook in which we had the implementation of speculative decoding without using AI coding tools. So we have a notebook of implementation of this. We went through this, we demoed this. You guys can run this in Colab and then see it for yourself. If you haven't, please go ahead and try it. If you see any issues or if you have any suggestion, either create an issue or leave a comment, or if you find any other use case that you would like me to go and record using AI coding tools, please leave the comment. But anyway, for this session, what we are going to do, we are going to for the second part, we are going to take the notebook, the Jupyter notebook that I implemented for speculative decoding, and then see if we use an AI coding tool like Cursor, how much useful the tool would be for, let's say, taking a Jupyter notebook as MVP and turn it to proper Python modules and code, let's say, for better maintenance. We just keep in mind this is improvisation, so everything is kind of we are going to do it in live, in kind of as we go, and then we kind of hopefully get some insight about this AI coding tools capabilities, limitation, how far we can push them. So without wasting a lot of time, let's go to this repository, and we want to clone this. So if I go to terminal, I already have the command for this. So we clone the repository simply speculative decoding, the repository in which we have the Jupyter notebook implementation of speculative decoding. So right now I'm there. Then I'm going to open Cursor, open that project. So go to that folder, just pick that folder so the Cursor knows what's the code base. Now the second thing that we are going to do over there, again, we have this speculative sampling OPT, which is a notebook. Now let's see if Cursor can refactor this for us and how can we prompt it. So I have a prompt here, so let's try to leverage this as much as we can. Here I have a Jupyter notebook called speculative sampling OPT, which has implemented a speculative decoding algorithm. I have a number of methods implemented in this notebook, and a simple example to test the code. Your job is to refactor my notebook by, let's restrict it by creating 2 Python module. One Python module will have all methods in which we run the draft, target models, and run speculative decoding sampling. Feel free to use Python classes if it's necessary. Also create another module and call it main.py, where you create an instance of the class of the speculative decoding class and run the code with the example that was used in the notebook. Keep your don't change the logic unless you find a bug in the implementation that you have to fix, that you must fix. Leverage, I don't need this. Do not write do not add extra or unnecessary code which is not important, which is not critical. Make sure everything you copy. Okay, this is not important. I don't think that I need this. Okay, create a source folder in the parent directory where you add the new implementation, where you add your implementation. If necessary, make sure there is no bug. Take care of all the dependencies that need to be installed to run the code, right? So something along those. So I kind of planned it. I kind of came up with the plan. So let's prompt it to make sure that hopefully we have not much speculation or verbose code. So let's see. So one quick thing, I don't know why it's creating this extra folder. It's not necessary, but it did create this extra folder that I don't like really. But let's run it. You don't need to create a folder inside the folder, okay? But anyway, that's kind of more like opinion. I think source was enough, but for some reason, it has a decoder pi. Let's see what and then it has the main pi. So far so good. So we skip doing it, and then I think there is requirements. I don't know how it kind of makes sense. Quick look, it's updating the readme. Okay, fine. And it says that pip install requirement and then run that code. Okay, sure, let's review quickly. This is this project implementation. Okay, fine. I don't think this is completely correct, but it seems it kind of updated some of the things that I didn't want to really get rid of. Was on these references. Why did you remove those references? But let's say I accept. Accept. Oh no. Then this is kind of redundant. I don't know this. It's kind of, maybe this is not it's not that's not a big deal. So let's go to decoder where the juice is. There is a class. Fine. It takes the draft model and then it takes the target model. That's good. Put them on Coda. That's fine. I think it copy paste my run draft method. Fine. It also brought the other method for getting probabilities from the target model. Perfect. I have this. I think these methods are already kind of, I think it made some improvement to my draft tokens. So let me show you so that you guys know how to compare So for example here, what you see, so it did some code improvement. Let's say if you look at my implementation, so okay, see this code, I mean I have for loop, but you can do for basically leverage list comprehension, and that's what it did here. So it got rid of my for loop. Perfect. For self.draft tokenizer decode, excellent. I don't need, so this my code is, I mean it's not a big deal, but it's not logic change, but better than my code for sure. This part seems okay. It did some improvement, and then this essentially is running that. Okay, cool. So let's do a quick test. Let me accept this. Let me, one thing that I don't, okay, and then we can quickly test this in a Google Colab. Okay, let's so I right now my environment is not set up for this, but let's quickly test this in Google Colab as I did previous my own notebook. I demo it in the part 1, so I'm going to basically quickly run, give a run, and then see if we quickly, if we can find any obvious bug. Okay, I just copy paste this. Okay, fine. One thing I'm going to do, I'm going to, so this is just quick run speculative decoding. So let's run this. So this is just refactoring of my notebook, and we want to see if it successfully runs. I don't need that import really inside the notebook. So let's just create the class, and then why is taking time? Okay, ran. Okay, now let's see what happens. So we create an object, we create this class, and then I think when we create the class, okay, it's going to download the models. Let's do this. So okay, it's downloading the smaller size model, the draft model. Now it's downloading, I think, okay, I think it's now downloading this bigger size model, 600 megabyte versus the other one which is 200 megabyte. Great. So the, okay, so that part is done. Now so we have this prompt that we also tested in our notebook. So basically we have this prompt, Paris is the capital of, and then what we do, we first run the draft model, we get the result. Okay, and then okay, let's do one by one. Okay, let's run the draft model, so because that way I can review. Okay, let's review this too quickly. It seems correct what I remember for the token IDs. So we'll be basically getting 5 token IDs from the draft model, completing this sentence. Okay, that's the first part. The second part is we are kind of passing that to the speculative decoding, where we just evaluate them. Okay, and okay, so when I ran, okay, let's go back to my okay, oh, unfortunately I don't have the Jupyter notebook output, I delete them. But if we run this, let's see how evaluation happened. Okay, so okay, in yes, the French Republic below, so these are the accepted token from the target model. So if we rerun this, we might have a different result because it's a probabilistic approach. Okay, this time the same thing, so let's put them side by side so that I can run both parts basically for evaluation together. Let's repeat the run. Okay, nice. So it seems, quick glance of it, it seems the implementation is correct. So now so it seems the implementation is correct. I accepted everything correct, and we have requirements.text. Okay, for now I have to basically also review them, but I will do that later on offline. I don't need that to do that in front of you guys. But essentially it seems we had a kind of good one thing that I just don't like is this extra foldering situation. I don't know, I just don't think that's necessary. So what I'm going to do, let's do this. So what I'm going to do, I'm kind of afraid if I'm going to mess up something, but so let's, I mean, okay, so let's forget it. Let's keep it as it is, whatever the, I don't, so it's not a big deal. So let's push whatever code we got. So essentially we refactor okay, why is complaining? I will fix this later, but for now I'm going to push this, but that's the video. So that's essentially our kind of demo. Essentially what we learned is that with the prompt that we gave, with this prompt, kind of our prompt, if you think about it, this prompt was a few iterations. So my first version of the prompt was very simpler. I essentially, in the very beginning, I only asked cursor to take my Jupyter notebook and refactor it. But what I found with that kind of simple prompt, where is you are not kind of putting a bunch of guardrails, what I found is that cursor might become verbose. It might kind of makes mistakes, add extra code that is we don't really need. So I think essentially what this version that I just had for you guys is kind of a few iterations that I had run offline. What I found is that okay, it's better to come up, break the problem, kind of divide it and conquer, and then coming up with a plan for cursor to execute, or for LLM behind cursor to execute on. So and then basically give a bunch of things that you don't want the cursor to do, and then kind of having a clear plan that, oh, I want only one class, sorry, one module decoder.py, and then move all of the logic there, and then create another run, let's say .py or main.py to just run the class. Okay, so and demoing how the speculative decoding works. So minimize the code, put the guardrails. So that's one thing that I wanted to share from my experience, and please keep this in mind. So if you have a complex task, always try to break it to a smaller piece, provide the context, provide the guidelines, provide the necessary guardrails so that cursor or the LLM behind cursor kind of follows those, and you minimize the amount of, let's say, cleanup or fixes that you have to do later on. Thank you.